And the example goes like this. It said, in a simple screw jack, the pitch of the screw is 5 mm and the length of the effort arm is 30 cm. If the efficiency is 10%, find the load that can be raised by an effort of 20 Newton applied at right angle. Now let's see how it goes. Solution. The first thing you do, you write out the parameters, which are the data given. So the data given are, we have the pitch P, which is given as what? The 5 mm. We have the effort E, the length of the effort, which is given as what? 30 cm. That is the length. The efficiency, which is given as 10%, right? And also, so we should now find the load. So we're looking for our L, which is something that's saying our W, which is the weight, is given. We're looking for that can be raised by an effort. So we're given the effort E to be equal to what? 20 Newton. The effort is also the force, because you need the force to, the effort you're applying is the force you're applying to leave the road, right? So from here, from this process here now, so now these are the given parameters, right? We're looking for the load. So what you do here is this. The velocity ratio of a screw jack, velocity ratio VR of a screw jack, is giving us 2 pi L all over what? The pitch, right? This is my equation 1. This is the formula for what? The velocity ratio of a screw jack. And we know pretty well that we are not given the velocity ratio, so we need to eradicate this velocity ratio here. So what you know now, you now recall that our efficiency is equal to what? Mechanical advantage all over what? Velocity ratio. Now, if I make my velocity ratio the same as the formula here, I'll be having velocity ratio is equal to what? Mechanical advantage all over what? Efficiency. So anywhere I see my velocity ratio in equation 1, I am going to place it, I'm going to put mechanical advantage over efficiency, right? So I'll put this, I'm writing this, so put VR in equation 1. So we'll now have that the mechanical advantage all over what? Efficiency, to replace this, equals to what? The 2 pi L all over what? The pitch. Are we good? So from here, we'll move forward. Now we have the efficiency. We don't have mechanical advantage, but recall our mechanical advantage is equals to what? The load over what? The effort, E, right? So anywhere I see the mechanical advantage, I'll put it in equation 1 here. In this equation here, let me call it, in this equation here, right? Let me call it equation 3. Right? So from here, before I even substitute in, I should make my mechanical advantage sort formula here. So I'll be having mechanical advantage is equal to what? 2 pi L all over P multiplied by what? Efficiency. Now I have multiplied, I have taken this to the other side. Are we good? So now let me substitute in my mechanical advantage so that it will be easier for us to use. So mechanical advantage is what? Length over load over effort, which is the weight over effort. So we have the load all over what? The effort, right? The load over the effort is equals to 2 pi L times the efficiency all over what? The pitch, right? So what we're actually looking for is the load. So if I make use of the formula, my load will be equals to what? 2 pi L times what? The efficiency all over pitch multiplied by what? The effort. So this is the load that we have here that we're looking for. So we'll start inputting our value. So this is our value that we have. The value we have here, we have the pitch to be 5 mm, we have the length to be 30 cm. Now, we want to convert 5 mm into meter. 5 mm to be 5 divided by what? 1000, and that will give me 0.005 meter, right? If I convert 30 centimeter into meter, it will be 30 all over what? 100, right? And that will give me 3 millimeter. So that will give me 3 millimeter. So let me just put it here. Let me remove this. I should remove this from here. So I'll be having 30 all over 100 will give me 0.3 meter. So that is my converting them into meter. I want them to be uniform. Either you convert one of them to centimeter, or you convert one of them to millimeter, or you convert both of them to meter. The same, they must have the same unit, right? So we're moving forward. So the pitch is 0.005 meters. The pitch is 0.005 meters, so I'll go there. So the pitch, our length now will now be equals to, so the pitch is what? 0.005 meter, right? Then the next one is, we have 2 times pi times the length. The length given here is given to be 0.3 meter. That is the length given, 0.3 meter. So we are going to apply the length here, which is 0.3 meter. The efficiency, which is 10%, and that will be 10 over 100, and that will give me 0.1, which is efficiency, multiplied by the effort given. The effort given is what? 20 Newton. That is 20 Newton, right? So in doing that, if you punch your calculator, you'll be having, 2 times pi. So to operate my pi, I'm going to press shift, then this is my pi here. So multiply by 0.3, multiply by 0.3, multiply by 0.1, multiply by 20, and this will give me 3.7699. So I'm having 3.7699 all over 0.005. So divided by 0.005, so we're having 753.98 Newton. So that is the load that is applied. So if you find this video helpful, please don't forget to click on the subscribe button.